All right, so let's look at this exponential function more closely and identify the range, the domain, and when it's increasing and when it's decreasing and all that stuff. Okay, so remember that A is your starting point. So if I put in a 0 for x, right, anything raised to the 0th, you'd know equals 1. So if x is 0, then a is whatever a is. It's whatever a is times 1. Okay, so that effectively gives you your or your y-intercept. When x is 0, right, this will be your a value. We'll say it's like right here. So in that case, a would be 2. Okay, right now, remember, if b is less than 1, this is going to shrink. It's going to get closer going this way. So this is b, that is between 0 and 1. Okay, not including, well, I guess we'll say b equals all values of I guess b, all values of b, such that 0, 1, no underline. So that's what we got going on here, right? So this, let's say it would do something like this. It would do something like this. Notice that it gets closer and closer and closer to 0, y equals 0. So y gets closer and closer to 0 the bigger that x is. And let's use a calculator to demonstrate that. So let's say that I have my b value and ends up being 0.5, right? If I raise that to the 0th, like I said, it's going to be 1. Okay, so 1 times whatever a is going to get smaller. So we're going this point, we're going that way. I'm going to make x bigger. Right now, so if I say x was 0.5 and I raise it to the 2, that means I'm going to multiply a by 0.25. Right? If I go x is 3, so where x is right here, right there, when x is 3, that's going to be 0.5 to the third. It's 0.125, so it gets smaller and smaller and smaller. Now let's say what happens when I say a is, or b, x is so 0.5 raised to, we'll say it raised to the 100th, right? It is that number, right? This is 7.8 with 31 or 30 zeros in front of it, right? So super, super close to 0. They put it in this annotation. This is scientific notation. They put it in this notation so that you don't have to show all the 30 zeros in front of this thing. Okay, if you remember scientific notation. So it's effectively 0. Like, in fact, if I go like 0.5 raised to the, it says it's 0. It's not, but it just can't put that small of a number in the calculator. Now conversely, let's see what happens when I go up like that. Okay, so if I make x negative, I go 0.5 raised to the, we'll say 1/2, right? It's gonna make it a little bit bigger, right? It's gonna be a little bit, it's gonna be this thing, 0.5 raised to the 1/2. Okay, yeah, so I effectively made, oh, sorry, it's 1/2. It's negative 1/2. 0.5 raised to the 1/2 negative. There we go. So now I made it bigger, right? So it's 1.4 approximately times whatever that a value is. In my example, a is 2. So it would be 1.4. It would be like 2.8. It'd be like 3-ish when it's negative 1/2. Okay. So what if it's like 0.5 raised to the negative 4, raised to the 4 negative, right? It's 16. It's gonna be way up here when x is negative 4. It's gonna be way off the chart, right? So that's what exponential decay does. The more I go toward negative infinity for x, the higher. So if I have negative infinity for x over here, and then I have positive infinity for y. That's a really bad infinity sign. All right, and then a negative infinity for y, and then a positive infinity, right, for x over that way. So the way we say this thing is, okay, so as x approaches negative infinity, y approaches positive infinity. Okay, and then as x approaches infinity, y approaches 0, right? Because this x equals 0 is an asymptote. Okay. So now let's take a look at what happens if I were to add like a 4 or a 5 to this, it would just raise that up, right? And then this whole term, let's say this was like plus 5, right? As x approaches infinity, this number effectively gets to 0, right? But I shifted this whole thing up to 5. 1, 2, 3, 4, 5. So it would look like this, right? And x is effectively going to approach, well, actually it's going to be approach my asymptote at 5, so it's going to be like way up here actually, 5 plus 2, so it's going to approach like that. Okay, so it reaches, ignore this. Okay, so it's going to, my asymptote shifted to 5 because it was 0, and now it's 5. So as this value approaches, as x approaches infinity, right, y approaches 5. It'll never get to 5, but it'll always be a little bit bigger than 5, but it'll never actually get to 5. Now what happens if I put like a negative sign in front of this whole thing, right? Let's say I have y equals a times b to the x, but instead it's negative, right? It's the same thing, right? It's the same thing except it's flipped, right? It'll be something like this. Okay, so it's going to take this and then flip it, make every value negative. And same thing if I shifted it to 5, my asymptote is now here, and it would just do this, like that. Okay? So those are decays when b is less than 0, or between 0, excuse me, when b is between 0 and 1. So what about when b is between all values of b such that it's greater than 1? B is greater than 1. Right, well that's going to be a growth, right? Because remember I have my equation. We'll say my equation is b, or y equals a times b to the x, right? And let's say, let's say that x is, it doesn't matter, my asymptote is still going to be here at 0 because it's plus 0, right? And instead it's going to do, say, when x is 1 or when x is 0, let's say that y is 1, right? Making this a term 1, right? But instead of decreasing, it's going to increase, right? And then if I were to, so that's the only difference. This is a growth. And you can kind of like run the numbers there, right? And if x is positive, it's going to make that b value more positive the bigger the number it gets. Okay? That's fairly intuitive. Okay? And if I were going to flip this thing, it would be like this. It would be like, oh boy, it would be like this. Okay? That's a negative growth. Okay? So it gets bigger and bigger and bigger versus a decay, which gets smaller and smaller and smaller from when I go left to right. So decay gets closer to 0 as I go from left to right, as x approaches infinity, and a growth becomes closer to positive infinity for y as x approaches infinity, or negative infinity. Okay. All right, hopefully that makes sense. Oh, actually, we can go over an example real quick. Okay, So here I can say that this is going to be decreasing. So as x approaches infinity, this thing, y, is going to go down. It's going to get closer and closer and closer to 0, and it is positive because this value is positive. It's an invisible positive sign right there. Okay, this is going to be an increasing, right? Because this value is greater than 1. This is greater than 1. This value is less than 1, right? So this is also positive. This is also positive because it's not negative. In order for it to be negative, this sign has to be negative. Okay, so here is a graph. Okay, and it's telling me, it's got all these numbers here. Okay, and it's asking me what the domain is. Well, the domain, for all intents and purposes for algebra, is usually going to be all real numbers, right? Because we're talking about everything from negative x infinity to positive x infinity, right? Now the range here, it will never reach 0, right? So 0 is going to be my minimum. So my range is going to be all values of y such that y, sorry, this would be range. Oops. All values of y such that 0, as x goes infinitely negative, right, y will be closer to 0, and x in infinity is going to be my maximum, and y is going to be somewhere in between there. It'll never reach 0, it'll never reach infinity, so I leave the underlines gone from these things. I leave them underlined. Okay? All right, so here we have, so the constant rate of change in percent, right? We just got to figure out what 9/5 is, right? So 9/5, it is 1.8, right? So this is an 80% constant rate of change. So you multiply it by 1.8 raised to the x, right? Because it's 9 divided by 5, which is 1.8. So it's an 80% raise, right? Meaning that it's every time I do this, I do 1.8 raised to the x. So that's 80% or 180% mathematically. Okay. Okay. So what is the y-intercept? Well, that's easy. When x is 0, y is 2. That's right there. Any zeros in your table values are important to know. Is it increasing or decreasing? Well, as x approaches infinity, y approaches infinity, both positive, so it's increasing. Okay, it's always positive. It never goes underneath the x-axis, so it's all real numbers. Okay, it's never negative. Okay, so it's never negative. Okay, so what about the left-end behavior? Well, the left-end behavior as x approaches negative infinity, y approaches 0. Never actually gets to 0, just like it never gets to negative infinity, but approaches 0. Then right-end behavior as x approaches positive infinity, so it's going this way, approaching positive infinity, y approaches positive infinity. Okay, so hopefully that makes sense. That's a good lesson there to kind of describe what happens with decays and exponential decays and growths.